This is step 2 of the final project of the intercom system. And in this step, we are going to start to write the Arduino code. I'm gonna write the Arduino code in 3 steps. First, to initialize all the components, and then to focus on the output, so what we send from the Arduino to the Raspberry Pi. And the third step would be to focus on the input commands, so basically what we receive from the Raspberry Pi, and apply those commands to the hardware we have previously initialized. I'm doing it this way. Why? Because, well, we already have all the hardware components plugged to the Arduino on the circuit. We know it's working because we already have tested them. And also in this project, well, there is no relation between all the components in the Arduino program. Only the Raspberry Pi will know how to combine them, okay, when to power on the LED, when to give some text to the LCD screen, when to ask to open the door, etc. But the Arduino doesn't know any of that. The Arduino just sends output messages and receives input commands and execute them independently for each component. So that's why I'm going with this order. What you could also do, and which is also a valid option, is to do the steps, so one step for each component. For example, if you were to start the circuit from scratch, you could add a component to the circuit on the Arduino, test this component, and add this component into the Arduino program until you have tested and added all the components one by one. Alright, so now let's start, and here in this step I'm gonna just initialize all the components and print something on the LCD screen, like a starting message, to just know that we have started the application. Also, for each step, I'm gonna save the project, okay, as a different file with the name of the step, so you can just download each program for each step independently. All right, let's start. So first, I'm going to include the libraries we need. And so for the RGB, the buzzer, and the push button, we don't need anything, but we need something for the liquid crystal. So liquid crystal.h and include servo.h. All right, we have all the libraries we need. And then I am going to do a define for each of the pin. So RGB, let's start with RGB. Red pin, which is pin number 11. And then RGB green pin, which is number 10. Okay, in this project, here in the solution of this project, I'm gonna write all the code from scratch. Define RGB blue pin, which is 9. Okay, we have the RGB. Let's do the buzzer. Define buzzer pin, which is pin 8, and then define button pin, which is pin 7. Okay, there is no order for this, we just do all the defines. Then, well, let's add the servo here. Define servo pin 12. Okay, we have the servo, RGB, buzzer, button, and then we need the LCD. So LCD RS pin A4. And then define LCD E pin, which is A5, and we have 4 more with LCD D4 pin, which is number 2. Let's just copy this 3 more times. D5, D6, D7, and we have 2, 3, 4, and 5. Okay, make sure you have the correct defines. That's gonna save you a lot of debugging time in the future. Now let's create the global objects we need for the liquid crystal and the servo. So let's start liquid crystal LCD. We need to give all those pins in the order. So RSE D4, and then let's align here with the parentheses. D5, D6, and D7. And let's do also servo. Let's name it servo. Okay, LCD and servo. We just have one, so let's name it LCD and servo. If we had multiple ones, you would give, of course, more meaningful names. Okay, For example, right door servo and left door servo. Here we just have one. Now in the void setup, so let's handle the void setup. I'm gonna initialize serial in the next step, okay, because here we just initialize hardware component. So let's start with the servo. Servo dot attach with servo pin. What we can also do for the servo immediately is to put it in the close position. So basically to close the door, to lock the door. So we're gonna do servo dot write, and here where you can play with the servo, you can just give different angles and put a plastic part on it to see which positions are gonna suit your project. And what you can do is you can create, let's create another two defines here. Define servo open door position, and let's define servo close door position. So that if we have this right now, then when we receive the command, we can just ask the servo to go to this position. And for me, I'm gonna use 50 and 140 degrees. Okay, we are not going to go from 0 to 180 here. I have just put two values in the middle, and you can see the difference here is 90 degrees. And so this here is the position where the plastic part that I've put on my servo is gonna be straight, so the door is not locked. And here we rotate it by 90 degrees to close the door, okay? A quick tip here I recommend is if you use a hobby servo motor, don't go to the extreme, okay? Don't go close to 0 and don't go close to 180. Try to stay somewhere in the middle, okay? But you can make your own experiment. You can use those values to continue with the project, but if you install the servo on a real door, then you might just experiment and choose different values. All right, so I'm gonna first write the servo close door position. Okay, we don't want the door to be open by default. We want the door to be closed by default. So we have the servo initialized. Now let's initialize the push button, for example, with pin mode, button, pin, input, and then pin mode, buzzer, pin, output. Let's do the RGB LED, pin mode with RGB red, pin, output. And let's do also the two other legs. So we have green and we have blue. And then we are left with the LCD screen. So LCD.begin 16 by 2. And we are going to print a welcome message, or just starting, LCD.print starting, like this. And what I'm gonna do is I'm gonna add just a delay here with 1000 milliseconds, so just 1 second, and then LCD.clear. So this I usually do in my Arduino applications when I have an LCD, is print something like starting for 1 second, 2 seconds, something like that, and then clear the screen so that we know when the program is starting and we know basically when we enter the void loop. And that's always a nice message to print for the user. All right, now that we have all of that, let's try, let's upload the code. Okay, so we should have the servo that goes to the closed position. We should have also starting printed on the LCD screen. So I'm gonna upload, let's make sure the board is here and upload. Let's name it intercom step 2. Okay, the step 1 was to define the protocol. Compiling and then uploading. Starting, you can see we had starting, and well, the servo is in the closed position. It was already here, so it didn't move, but you can see here the closed position is the lock mechanism will be like this, and the open position, the lock mechanism will be up, okay, like this. Close and open. Okay, and we have just finished the step 2 of the project, so not the most interesting one, of course, but a necessary one, so then we can focus on the application because we have everything correctly initialized.